It's no secret that Io, the closest of Jupiter's Galilean moons, is quite unlike anything else in our planetary system. It's also different from asteroids, comets, and other objects. The surface of the moon is not what we might have imagined. There isn't a single crater on Io, and it's unique in that way. You won't find any water here in any form either. This is a raging, lively world where volcanoes erupt continuously. There have been times when several eruptions happened at once, and the number of active volcanoes on Io has reached 400. Constant metamorphoses are happening on the surface of the satellite. Its hot crust is constantly being deformed under the powerful gravity of Jupiter. What secrets does the mysterious satellite hold? Io subtitles, welcome to our geography deadlines. We know that the moon's gravity causes tides, raising the water level of Earth's oceans, but on Io, the tides are about 88,000 times stronger. The differences don't end there. The gravity of Jupiter and its moon Europa affects Io daily, moving the solid crust of the moon upward, not water. Why does this happen? There is a strong theory that, again due to Jupiter's gravity, friction occurs, which leads to the heating of Io's surface. Jupiter's gravitational influence is so powerful that the moon's crust is torn into pieces, and there is movement relative to the mantle. That's how we get liquid magma inside Io. It expands greatly in volume, which is why it bursts to the surface. Previously, it was widely accepted that liquid rocks fill the gaps between the mantle and the crust, that is, between solid rocks. Further research revealed that the actual locations of volcanoes do not match the supposed areas. Eventually, scientists concluded that there is a layer of liquid magma on Io that remains in this state constantly. When we try to explain the cause of the intensity and location of eruptions, we should use a comprehensive approach. They are limited to two factors: heating and gravitational influence. Only the combination of heating of solids the hybrid model, which takes into account the liquid component, most accurately describes the increased volcanic activity in the equatorial zone and the eastward shift of volcanic eruptions. At the same time, solid rocks being heated under the influence of Jupiter's tidal gravitational forces can explain volcanic eruptions specifically at higher latitudes. In this picture, you can see the results of modeling the heating of Io's surface, which comes from the depths of the mantle at the top and from the upper layer of the mantle, namely the asthenosphere at the bottom. In one case, the temperature increases closer to the poles, and in the other, near the equator. The gravitational influence of Jupiter is so powerful that liquid rock may be constantly bubbling beneath Io's surface, and that's truly amazing. This information suggests that underground oceans may be hidden beneath the ice of Europa and Enceladus. Just think about it. With liquid water, if Jupiter's gravity can help raise the temperature and maintain the necessary level, especially in the layers of liquid water, then life could emerge and develop on these moons, even if it would be quite unusual. Recently, the research probe Juno provided us with a new batch of information. It took new pictures of the surface where scientists observed some features of the terrain, namely fiery islands located in the center of a lake and a rather high mountain. Later, a special visualization was created to better examine these areas. You could also enjoy an animation of Patara Loki Lake, which is a lava lake with a diameter of over 200 kilometers. As expected, Juno's camera also captured a huge number of volcanoes, some even in the process of erupting. Further research of the collected data also made it possible to discover areas on Io where the surface was very smooth. What conclusions can we draw from all this information? Most importantly, we know that there are a huge number of lava lakes on Io's surface, and their structure is quite unusual. They have something like a ring of hot lava that comes out from the inner layers of the moon, And the main part of the lake is a dense layer of molten crust. Infrared images have given us a clearer understanding of the features of such lakes. The absence of lava flows at the edges of the lake and beyond indicates the existence of a kind of balance. The molten mass erupting into the lakes moves back into the subsurface system. The lava often hits the edges of the lake, thus forming the walls. That's why this structure resembles a ring, since the height of such walls can reach hundreds of meters. The lava stays within the lake and doesn't spill outside. In these areas, mainly rocky formations prevail, which periodically rise and fall. They move as a single whole, being influenced by the central magma uplift. And so there is a suggestion that sliding of the crust is impossible there, since in these areas, there is friction between the crust and the walls of the lake. Eventually, such structures are destroyed over time, releasing lava masses to the outside. Of course, there is another explanation. Magma gradually accumulates in the central part of the lake, and at some point, the upper layer sinks at the edges. What conclusion can we draw? On Io, many geological transformations occur daily. The mountains on the satellite are quite high. For example, the highest point on Io and one of the highest points in the solar system is Mount Yuzhnaya Basavla. Its relative height is 18,200 meters. That's more than twice the height of Everest. The volcanoes on Io are so powerful that they eject huge clouds of sulfur and sulfur dioxide. Io is different from other satellites of Everest by the elements that form its structure. Io is mainly composed of silicate rocks as well as iron, which makes up its core. At the same time, the satellites in the outer part of our planetary system contain mostly water ice. Io has poles where the temperature differs from other areas due to intense volcanic activity. On the plains, a layer of frozen sulfur dioxide and sulfur settles. Of course, we will never be able to colonize Io, since the conditions there are, to put it mildly, not suitable for humans. However, by studying such moons, we form a clearer picture of how the universe was formed and what limitless possibilities exist in this vast space. And what do you think? Will we learn anything more interesting about Io in the future? Curiosity and Perseverance have become some of the most famous Mars rovers in history, and their missions are still ongoing. Right now, they are 235 million kilometers away from our planet. The rovers are tirelessly working to help humanity gain more information about the red planet. Now, we rarely encounter the problem of data being delivered too slowly to Earth, and the research probes are almost able to show us what's happening on Mars in real time. We've talked a lot about the interesting things that were discovered on the planet in the past, but today we're inviting you to find out what new things the rovers, Curiosity, Perseverance, and others have found for us. Let's start with the achievements of Curiosity and Perseverance. Thanks to them, we received images of the Jezero crater. Here we can see traces of sedimentary rocks on the slopes, and it's also interesting to look at the Belev crater. One of the oldest craters. In some images, we can see areas where most likely there were once water flows. And here are images of the Valinor Hills. They contain rocks that serve as evidence that there was once a huge sand spit there. The automatic interplanetary station of the European Space Agency, called Mars Express, has provided us with a rather curious image. You can see frost on the volcano Ali. It's not there all the time, but appears for a short period before the sun rises. It is worth noting that the frost contains more than 110 million liters of water, and there is a regular exchange of this water with the planet's atmosphere. Look at these icy spots up close, isn't it beautiful? The terrain of Mars is much more interesting than it seems at first glance. For example, there are cracks that even vaguely resemble honeycombs. Other research devices also get into the frame. For example, here we can see the robotic reconnaissance drone Mars Ingenuity, which completed its mission in 2024 because it damaged one of its parts during operation. The world of the red planet is a world full of mysteries, where there are still objects that can surprise us. And quite possibly, if we ever colonize Mars, this will become a familiar view from the window of a research station. And what do you think? Is it possible? In the era of rapid space discoveries, sometimes it seems to us that we know almost everything about our universe, but that's far from the truth. Moreover, some facts that we've always taken for truth actually aren't, which is already a scientific fact that's little known to the general public. What secrets has the universe revealed to us? And what is the true face of space? Let's start with something simple. You've probably watched Star Wars or other science fiction movies where spaceships explode epically in space and burn to ashes. In reality, nothing like that could ever happen. There's no oxygen in outer space, which means an object can't just burst into flames, and there can't be a shockwave either. What a disappointment. But here's our sun. So, what new things can we learn about it? But what if we told you that it's actually like this and not like that? And yes, you could say that the real color of the sun is green, but why is it that in all the pictures it's orange, yellow, red, white, but never green? We already know that you can determine a star's temperature using the color spectrum. Simply put, each color has a certain wavelength that comes from the star. The coldest stars are red, and the hottest are blue or blue-white. Our sun emits most of its waves in the greenish spectrum, but it also emits waves of other wavelengths. That's why we see a mixture of colors, which turns into white light. In many photos, the color of the sun can look different. For example, our main star actually appears yellow if you look at it from the International Space Station. This happens because waves close to the blue spectrum are scattered by the atmosphere. In reality, the sun can't be yellow at all, except maybe in children's drawings, because in that case, our planet would be a barren, inhospitable place located outside the habitable zone of the solar system. And the reason for this is that a yellow sun would have a temperature about 800 degrees Celsius lower. Besides that, have you ever wondered how the sun stays so hot? Of course, it's not as powerful as it used to be, but it's still scorching, not unique. The process of burning itself doesn't actually happen on the sun because it would require a huge amount of oxygen, which is almost non-existent there. The sun is mostly made up of helium and hydrogen. Rather, it's the perfect environment for nuclear reactions to occur. Thanks to them, our main star is so hot. As you know, Mercury is the closest planet to the sun, so it turns out it's also the hottest. It's not that simple, of course. The conditions are like ashes from ashes and Allegro follows from the gases of the Earth. Its captain needs to be a master of his craft to avoid colliding with one of the asteroids. It's true, right? But actually it's not, and once again, space movies create a complicated picture for us. No, of course not. There are trillions of objects of various sizes in the asteroid belt, and many of them could easily crush a hypothetical spaceship. But that's very unlikely, and that's because they are separated from each other by a very great distance. That's why you can cross the asteroid belt and never actually encounter an asteroid at all. Usually the distance between asteroids is more than twice the distance between the Earth and the Moon. It turns out that it's not as epic as we imagined. Let's move from the asteroid belt a little closer to our planet. Have you ever wondered how many stars we see in the night sky? There seem to be infinitely many, making it impossible to know the exact number. However, scientists from Harvard University took on the challenge and found out that from Earth, without using a telescope, we can see 9,110 stars. Impressive. Now let's talk about the entire solar system. We know that the planets orbit and rotate around their own axes, but you should also know that the system itself revolves around the center of the Milky Way. It completes a full revolution in just 230 million years. Just imagine, the last time Earth was in the same place it is now, dinosaurs were walking on it, and humanity was still a long way from appearing. But what if we told you that all the planets actually don't revolve around the sun? Of course, the sun can be considered the center of the planetary system, but it's not that simple. Scientists have found that the orbital motion of the planets happens around the so-called center of mass of the solar system, or simply the barycenter. In some cases, it is located inside the object, providing a balance of gravitational mass, and most often, the center of mass does not coincide with the sun. In the case of Earth, the barycenter almost coincides with our star, but in the case of, say, Jupiter, it shifts by about 55,000 kilometers. And what would happen to a person if they were thrown into open space without a special suit? The most obvious thing is that he would just lose consciousness in the first 15 seconds due to lack of oxygen. Then within a few minutes, his organs would stop functioning, and that's it. Inevitable death. There's also a risk that the human body would simply start to swell up, turning into a balloon, all because of nitrogen bubbles that would start to appear in our blood. By the way, the threat of freezing would be minimal, since in the vacuum of space, these processes happen very slowly. Oh right, we haven't told you yet that there's no coronavirus or such temperatures in outer space. We can't even say for sure that space is cold. Temperature is determined by how much energy particles release and how fast they move, but in a vacuum, particles can't move. Accordingly, in this case, we can't really talk about the concept of temperature. Unfortunately or fortunately, space is not an absolute vacuum. In some areas, for example, there are stars whose particles emit heat. As you know, there are no stars in space. It only screams with silence. However, that's not entirely true either. Indeed, particles are too far apart for sound to travel a significant distance, but there are still objects in space that have enough particles to transmit sound. For example, this is what a cloud of hot gas sounds like around a black hole in the Perseus galaxy cluster. Our universe is full of mysteries. Sometimes we think we've solved some of them, but time shows that this isn't the case. The AceCap radio interferometer, located in Western Australia, began detecting a repeating signal. It appeared every hour, and the properties of the signal changed from time to time. So, where does this signal come from? A white dwarf or a neutron star? At the same time, the characteristics of the signal themselves don't even hint at that. So what is it then? Is it interference from research probes from unknown cosmic objects? Or is it an attempt by alien civilizations to contact us? As you already know, in space we can't detect sound signals because there's a vacuum out there. However, our research probes detect other types of signals, such as radio, X-ray, and gamma electromagnetic signals. Only then do they convert the received data into audio tracks. Usually the signals we receive are trivial and have already been thoroughly studied by us. However, in the case of the ASCAP telescope, everything was different. The signal it received behaved differently from other similar ones. Sometimes the pulses were weak, sometimes strong, and in some cases there were none at all. The scientists named this signal J 1935-2148. Upon detailed investigation, it turned out that the direction of the signal was not constant. It changed depending on the point in space through which the signal passed. This is called circularly polarized waves. The scientists also learned that the object emitting the signal has 3 phases, affecting its characteristics. The first phase lasts from 10 to 50 seconds, producing linearly polarized pulses. The second phase lasts about 370 milliseconds, during which the strength of the pulses noticeably decreases. The third phase is the absence of pulses. This 3-phase signal repeats every 54 minutes. The source of the signal is considered one of the slowest objects, but in fact, we know almost nothing about its origin. Scientists have a few theories. The object might be a white dwarf or something else. Figuring out what this means, figuring it out is a challenge. It will happen when Obo returns. Nanai, or the number of interrelation, physically changes. When a star settles, its signal can be affected by the magnetic fields of both objects, but inconsistencies remain. Neutron stars rotate in a second or less, making it hard to slow their rotation. With a white dwarf instead, the desired rotation period is possible. However, we face the problem that we don't know how such an object emits this kind of radio signal. And now we come to the most interesting theory. These strange signals are of artificial origin. In other words, they are being sent to us by representatives of an unknown extraterrestrial civilization. To understand how viable this theory is, let's go back to the past. To 1977, when a radio telescope called the Big Ear detected a signal with unusual characteristics. It was named the WOW signal. One of the researchers wrote this on the decoding sheet, and for quite a long time, the popular theory was that it was sent to us by aliens. The duration of the signal was 72 seconds, and after decoding, it turned out to be a one-time event that never repeated. Scientists couldn't find the exact source of the signal, but they identified its direction. It came from the constellation Sagittarius near the Milky Way center, an area with many galactic objects. Later, using data from the Gaia telescope, they found 15 potential stars that could have been the source of the radio waves. The most likely candidate was a star called Tumas 19281982, which is about 1,800 light years away from us. After the WOW signal was detected in 1977, a huge number of radio telescopes tried to detect it again. The last time, in 2022, a detailed study of 15 possible candidate stars was conducted, but no sufficiently strong signal was found. Also, there were no exoplanets found along the way, but we learned that there was a source of artificial radiation near these stars. During this time, the signal could have repeated if it were stationary, meaning its source would have remained in the same place. Therefore, there's a suggestion that the signal came from a spacecraft moving at high speeds, if the signal really does come from representatives of an extraterrestrial civilization anywhere at all. Why isn't the alien hypothesis dismissed immediately? In digital communication, encoding of incoming data is always used. Without knowing the basics of how the message code is created, it's not only impossible to decipher it, but it's also hard to distinguish it from ordinary cosmic noise. But at the same time, researchers are confident that any code can be deciphered if you have a sufficient portion of the message. And here's an example for you. During World War I, Troy, the British were able to decipher the German Enigma code by figuring out that the message contained information about the weather, so they used the word weather to break the cipher. Similar signals from pulsars, which are always present in outer space and well known to us, can serve as guides or markers for extraterrestrial messages. Researchers believe that extraterrestrials might use pulsars for navigation in space, and this could become a key tool in deciphering their signals. Even the hypothesis's authors admit that in the original. The study of signals that come to us from space. The subject is unknown, incredibly fascinating, and full of unsolved mysteries that have been troubling scientists and enthusiasts around the world for many years. However, we have a long way to go, and will need to put in an incredible amount of effort to understand their nature and unravel the mysteries hidden from us in these radio waves. Each new study brings us closer to the answer, but it will take much more time and effort to fully understand. Or is it just our imagination that we're making progress in this matter? Will we ever be able to uncover all the secrets of these mysterious signals and understand what they mean? Only time will tell. Well, Earthlings, this isn't the end of the video. We still have some truly interesting and spectacular episodes ahead. But for me to keep delighting you with all the characters of the cosmic expanses, I need your feedback. You can express it quite simply. All you need to do is give an electronic like under this video, because we simply don't have any other likes. And I know how to finish the phrase. This way, you'll let us know that we're moving in the right direction. Stay tuned.